Good morning. Welcome to Trinity online classes. I am VVN Suresh Kumar, lecturing mathematics. The common tangents to the circles x square plus y square minus 6x equal to 0, comma x square plus y square plus 2x equal to 0 form which type of triangle? Forms which type of triangle? The given circles are first one is x square plus y square minus 6x equal to 0. Second one is x square plus y square plus 2x equal to 0. First, to find the position of the circles. What is the relative position of the circles? First, we find this is of the form plus 2g1x plus 2f1y plus c1 equal to 0. 2g1 equal to minus 6, g1 equal to minus 3. There is no f1 term, 2f1, because there is no y quotient here. Here y quotient is 2f1, 2f1 equal to 0, f1 equal to 0. There is no constant term, therefore c1 equal to 0. Center of the first circle is c1. Actual formula is minus g1 comma minus f1, that equal to minus of minus 3 comma 0. Radius of the first circle is r1 equal to square root of actual formula g1 square plus f1 square minus c1, that equal to square root of g1 square means minus 3 whole square plus 0 minus 0, that equal to square root of 9, that equal to 3. Therefore, radius of the first circle r1 equal to 3. Center of the first circle is 3 comma 0. This is also in the form x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. Here x quotient is 2g2 equal to 2, g2 equal to 1. Here y quotient is 2f2. Here there is no y term, that equal to 0. f2 equal to 0. Here constant is c2. There is no constant term, c2 equal to 0. Center of second circle is center minus g2 comma minus f2, that equal to actually g2 is 1 minus g2 minus 1 comma 0. Radius of the circle is r2 equal to square root of g2 square plus f2 square minus c2. Square root of g2 square means minus 1 whole square plus 0 minus 0. Square root of 1, that equal to 1 radius. Next, c1 c2. Here c1 is minus 3 comma 0. c1 is 3 comma 0. c2 is minus 1 comma 0. c1 c2 equal to square root of 3 minus of minus 3 plus 1 whole square plus 0 minus 0, that equal to 16. c1 c2 equal to 4. And also find r1 plus r2. Here the r1 value is 3, r2 value is 1. 3 plus 1, that equal to 4. Therefore, c1 c2 equal to r1 plus r2. The circles touch each other externally. c1 c2 equal to r1 plus r2. The circles touch each other externally. Here one center is 3 comma 0 and the center is minus 1 comma 0. The y coordinates are zeros. The points lies on x-axis. And also here also find the external center of similitude. Minus 1 comma 0, c2. The radius of second circle is 1. and this is 3 comma 0. Radius of the first circle is 3. This is both the circles have no constants, and that means the two circles must passes through the origin. Therefore, the point of intersection B, the point of contact B, origin. The circles touch each other externally, and the point of contact is origin. Because there is no constant term, the first circle is passes through origin. There is no constant term. Second circle is also passes through origin. These two circles are touch each other. That means the two circles are intersect at single point. That point also be origin. This is the center of the second circle, C2. This is the center of the first circle, C1. Here there is totally the common tangents, two common tangents. We verify external center of similitude. External center of similitude. External center, circles touch each other externally. Circles touch each other externally. The number of common tangents is 3. Circles touch each other externally. The number of common tangents are 3. 2 are direct common tangents. 1 are transverse common tangent. We find the point of intersection of direct common tangents is external center of similitude. First we find the external center of similitude. External center of similitude divides the segment joining C1 3 comma 0 C2 minus 1 comma 0 in the ratio R1 is to R2. In the ratio R1 is to R2. R1 is 3, R2 is 1, 3 is to 1. Actual formula is mx2 minus nx1 by m minus n, comma my2 minus ny1 by m minus n. That equal to 3 into minus 1 mx2 plus nx1 minus of 3 into nx1. That means 1 into 3. That means 1 into 3. 1 into 3. M minus n, 3 minus 1, comma 3 into 0 minus 1 into 0 by 3 minus 1. That is equal to minus 3 by 2, comma 0 minus 0 by 2. Minus 6 by 2, comma 0. That equal to minus 3, comma 0. The external center of similitude may be named as A. It is named as A. The point A is minus 3 comma 0. Minus 3 comma 0 lies this side. Therefore the circles touch each other externally. These are the direct common tangents. This is the transverse common tangent. We named as the point of intersection of the direct common tangent, external center of similitude A, that is minus 3 comma 0, and C2 is minus 1 comma 0, C1 3 comma 0, and this is normal perpendicular to the tangent. This is called the distance from any point on the circle to the center is radius, that is 3 units. The distance from, this is normal. The distance from center to any point on the circle is, this is D, this is E. This is length of this value is 1 because radius of the second circle is 1. This is origin A. We find length of AC2. The distance between the 2 points AC2, square root of minus 3 minus of minus plus 1 whole square plus 0 minus 0 whole square. That equal to square root of 4 plus 0, that equal to 2. The distance between these 2 points is 2. Let we take this angle is alpha. We know that the properties of the common tangents of the circles, external center of similitude, center of the second circle, center of the first circle, point of contact, these 4 are actual internal center of similitude. These 4 are collinear points, and also the line divides the external center of the angle of external center of similitude in two equal parts. That is, this line is the angular bisector of this angle. This line is the angular bisector of this line. The line divides the angle at the external center of similitude in two equal parts. That is the angular bisector. Suppose this angle is theta, this angle is also theta. In this situation, we take one perpendicular line here. The diagram is written like this. Again, in this is point A, this is C2, this is C1, this is the line. Actually, this line is perpendicular to that. The length is one unit. The length is 1 unit. The angle may be theta. This is another angle. Its length is 2 because the length of ACT is 2. We take in right this named as this is E, named as this is B, this is C. In triangle AEC, for this AEC is a right angle triangle. AEC2 is a right angle triangle. For sin theta equal to opposite side by hypotenuse. In right angle triangle, for hypotenuse is the opposite side of the right angle. Here right angle is E at the angle, the hypotenuse is AC2. In the right angle triangle AEC2, for sin theta equal to opposite side by hypotenuse. That means EC2 by AC2, that equal to 1 by 2. Therefore, sin theta equal to 1 by 2, theta equal to 30 degrees. Sin theta equal to 1 by 2, therefore theta equal to 30 degrees. The angle theta that equal to 30 degrees is commenced. Next, this is the right angle triangle. We take a perpendicular from C2. Or we take AOB, another triangle AOB. Here this is perpendicular to each other. We take another triangle. The angle between AC2, this is E, this is B, this is A. The angle is 30 degrees. This is right angle. The angle is 30 degrees. This is right angle triangle, 90 degrees. We know that the sum of the angles in the triangle is 180 degrees. We know that the sum of the angles in the triangle is 180 degrees. In this triangle is O, this is O. In the triangle, sum of the angles in the triangle is sum of the angles in the triangle EB. (180 degrees). Therefore, the triangle AOB for, that is right angle triangle, the triangle AOB for angle A plus angle B plus angle O equal to 180 degrees. Here 30 degrees plus angle B plus angle O is 90 degrees equal to 180 degrees. Therefore, angle B equal to 90 plus 30, 180. 180 minus 90 plus 30, that equal to 120. Angle B equal to 60 degrees. Similarly, we apply this property. Another triangle. Similarly, we apply this property from the another triangle AOC. This line is angular bisector at the point A. That indicates two angles are same. the angle divides in two equal parts. This is theta, this is theta. The value of theta is 30 degrees. The above value is 30 degrees and below is 30 degrees. This is also 30 degrees. This is a right angle 90 degrees. Like maybe theta. Therefore, this theta 1. We know that the sum of the angles is 180 degrees. Therefore, angle A plus angle O plus angle C equal to 180 degrees. Therefore, angle C equal to 180 degrees minus angle A is 30 and the angle O is 90. That equal to 180 minus 120, that equal to 60. Angle C equal to 60. Finally, we got in a triangle ABC for B is 60 degrees, angle B is 60 degrees, angle C is 60 degrees. This spot is 30, this spot is 30. Total angle is 60 degrees. All the angles of the triangle are equal. Therefore, the angles of the triangle, angle A equal to, angle B equal to, angle C, that is equal to 60. All the angles of the triangle are equal. The given triangle forms an equilateral triangle. Actually, question is the common tangents to the circle. This is the one of the common tangent. That common tangent is transverse common tangent. Remaining two tangents are direct common tangents. One is ABD, another one is AC. Therefore, first we find, this is the question, the common tangents to the circles form which type of a triangle. First we find the position of the circles. The circles are touch each other externally. In this case, three common tangents are formed. Two are direct, one are transverse. This is the required triangle ABC. This is the triangle formed by the common tangents, that is ABC. First, we know that this C2 is minus 1, 0, C1 is 3, 0. First, we find the external center of similitude. External center of similitude A is minus 3, 0. And we find the distance between AC2. The distance between AC2 is 2 units. Actually, they perpendicular drawn from E to the C2. That is normal perpendicular. This is also radius R2. This is also radius R1. That is value is 3. Actually, another diagram. This is the angular bisector. That is, first part may be theta, second part may be theta. Because angular bisector, the two are equal parts, theta and theta. The distance between AC2 is 2 units. This is the right angle triangle. AEC2 be the right angle triangle. In right angle triangle, for sin theta equal to opposite side by hypotenuse, the length of the opposite side, because it is the radius, radius R1 equal to 1, and the distance AC2 opposite to the right angle is the hypotenuse is 2. Therefore, sin theta equal to 1 by 2, theta equal to 30 degrees. The angle theta is 30 degrees. We take our required triangle ABC. This angle be same. This is the line. This is the another line ABC. Triangle ABO for this angle is 90 degrees and here the angle is 30 degrees. We know that the sum of the angles in the triangle be 180 degrees. The remaining angle be 60 degrees. Here angle B equal to 60 degrees. Same property is applied below the triangle AOC for angle C equal to 60 degrees. This spot is 30, this spot is 30, total 60. Angle A is 60 degrees, angle B is 60 degrees, angle C is 60 degrees. Three angles are equal, that is 60 degrees. Therefore, the given tangents forms an equilateral triangle. Two circles with radius R1 and R2, R1 greater than R2 greater than or equal to 2, touch each other externally. If alpha be the angle between the direct common tangents, then alpha equal to R1 be the radius of the first circle, R2 be the radius of the second circle, and R2 is always greater than or equal to 2. R1 is greater than R2. That means the circles touch each other externally. Therefore, R2 is the small value. These touch each other externally. The circles are like this. Let alpha be the angle between the direct common tangents. Actually, in this case, three common tangents possible. Touch each other externally, three common tangents are possible. This is the line joining the centers. This is small circle is C2, largest circle is C1. Direct common tangents are possible. This is the angle. That angle B, if alpha be the angle between the direct common tangents, the angle is alpha. This is the perpendicular normal of the circle. This is length of the radius. This is R1. Sorry, this is the largest circle R1. This is R2. This is R2, that is R1. This part is alpha by 2. Last problem we discussed, this is the angular bisectors. The centers joining line is the angular bisectors at the external center of similitude angle. This is alpha by 2. We take one perpendicular to C2 to this line, then it will be M. This is one of the perpendicular line. This line is parallel to the first direct common tangent. That this is the line joining the centers. This line is direct common tangent. We take a line parallel to direct common tangent. This is perpendicular. This angle is also perpendicular. This is alpha by 2. This is also alpha by 2. This is the right angle triangle C2. M is the right angle. C2, M, C1 is the right angle triangle. Right angle triangle for opposite side. The distance between the two centers C1, C2. In this case, the circles are touch each other externally. That means C1, C2 equal to R1 plus R2. Therefore, the distance between the two centers is R1 plus R2. And MC1, the total length is, these two are parallel lines. This total length is R1. This part is R1 minus R2. This part is R1 minus R2. We take MC1 equal to R1 minus R2. MC2 equal to, we take this is angle alpha by 2. Therefore, sin alpha by 2 in triangle C2MC1 for, in triangle C2MC1 for sin theta equal to opposite side MC1 by hypotenuse. Opposite to the right angle is the hypotenuse is C2C1, that equal to R1. MC1 is R1 minus R2 by R1 plus R2. This is sin alpha by 2. Alpha by 2 equal to sin inverse of R1 minus R2 by R1 plus R2. Therefore, alpha equal to 2 sin inverse of R1 minus R2 by R1 plus R2. Therefore, alpha equal to 2 sin inverse of R1 minus R2 by R1 plus R2. Center of the circle inscribed in a rectangle formed by the lines. That means find the center of the circle inscribed in a rectangle formed by the lines. First split the given lines. Formed by the lines x square minus 8x plus 12 equal to 0. Factors 12 minus 6 minus 2. X square minus 6x minus 2x plus 12 equal to 0. X common, x minus 6 minus 2 common, x minus 6 equal to 0. X common, x minus 6 minus 2 common. Total x minus 6 common. That is x minus 2 equal to 0. Either x minus 2 equal to 0, x equal to 2. X minus 6 equal to 0, x equal to 6. These are two lines. One line is x equal to 2, x equal to 6. Any line, this line is parallel to y-axis because x equal to some constant. The second equation, y square minus 14y plus 40 equal to 0. Y square minus 14y plus 40 equal to 0. For 40, okay, minus 10 minus 4. Y square minus 10y minus 4y plus 40 equal to 0. Here y minus 10 minus 4 y minus 10 equal to 0. Common y minus 10. Y minus 4 equal to 0. Y minus 10 equal to 0. Y equal to 10. Y minus 4 equal to 0. Y equal to 4. These are the boundaries of the lines. These are the sides of the rectangle. The center of the circle inscribed in a rectangle formed by the lines. Our required circle is inscribed the sides of the triangle, rectangle. First, this is the circle. This is one line. This is one line. Rectangle formed by this x equal horizontal line is parallel to x-axis, that is y equal to 4. This line is y equal to 4. This line is y equal to 10. Y equal to 4 and y equal to 10. Another two lines are x equal to 2 and x equal to 6. X equal, this is x equal to 2, this equal to x equal to 6. We know that the midway of the line, two lines are parallel tangents of the circle. The midway of the parallel lines passes through the center of the circle. His x equal to 2 is the one of the line, x equal to 6 is the one of the line. These two lines are parallel and parallel tangent to the circles. Then the midway of these lines passes through the center of the circle. Therefore, the midway of the line is x equal to 2 plus 6 by 2, that equal to 8 by 2, that equal 4. This is x equal to 4. These two are parallel tangents. And that means these two lines are parallel and tangents to the circle. Then the midway of these two lines passes through the center of the circle. And similarly, these two lines are parallel tangent to the circle. Therefore, the midway of these line passes through the center of the circle. The midway of these line passes through the center of the circle. That equal to y equal to 10 plus 4 by 2. That equal 14 by 2, 7. This equation of the line is 7. This line equation is 4. Therefore, the center is 4, 7. X coordinate is 4, y coordinate is 7. Any line parallel to y axis, that is x equal to some constant. Any line parallel to x axis, that is y equal to some constant. The point of intersection of the line x equal to 4 and y equal to 7 is 4, 7. Here the point is any two lines parallel to the circle, that means parallel tangent to the circle, the midway of these two lines passes through the center of the circle. Actual original formula is ax plus by plus c1 equal to 0, one of the line equation. Ax plus by plus c2 equal to 0 be the another line equation. The midway of these two lines is, because these two lines are parallel, the midway of the line between the two lines is ax plus by plus c1 plus c2 by 2 equal to 0. Here these lines are parallel to y-axis, the lines are parallel to x-axis. The problem is solved simply. Therefore, this is the required center 4, 7. Equation of circle touching the lines modulus of x minus 2 plus modulus of y minus 3 equal to 4 is, these are the four lines. The touching lines are, the given lines are modulus of x minus 2 plus modulus of y minus 3 equal to 5. That means x minus 2 plus y minus 3 equal to 4. This is 1. X minus 2 minus y minus 3 equal to 4. Minus x minus 2 plus minus x minus 2 minus y minus 3 equal to 4. Next one is minus x minus 2 plus y minus 3 equal to 4. These are the 4 lines. The first line is x minus 2 plus y minus 3 equal to 4. X plus y minus 5 minus 4 equal to 0. X plus y minus 9 equal to 0. Plus minus plus. X minus 2 minus y plus 3 equal to 4. X minus y plus 1 minus 4 equal to 0. X minus y minus 3 equal to 0. Minus x plus 2 minus y plus 3 equal to 4. Minus x minus y plus 5 minus 4 equal to 0. Minus x minus y plus 1 equal to 0. X plus y minus 1 equal to 0. Minus x plus 2 minus x plus 2 plus y minus 3 minus 4 equal to 0. Minus x plus y 2 minus 3 minus 1 minus 4 minus 5 equal to 0. X minus y plus 5 equal to 0. These are the 4 lines. In this case, this line is parallel to this line. Equation of the circle touching the 4 lines. That means these 2 lines are parallel and these 2 lines are parallel because these parts are equal. Maybe the circles become, suppose 2 lines. The 2 lines are x plus y minus 9 equal to 0. This is x plus y minus 9 equal to 0. This is x plus y minus 1 equal to 0. The remaining 2 lines are also parallel. These 2 lines are perpendicular to each other. This is x plus y, this is x minus y. One is, these are 2 lines. These 2 lines are parallel. Last problem we discussed. The midway of this line is passes through the center of the circle. The midway of these lines is passes through the center of the circle. Therefore, the midway of these 2 lines is, midway line is that is x plus y plus minus 9 minus 1 by 2 equal to 0. That equal to x plus y minus 10 by 2 equal to 0. X plus y minus 5 equal to 0. The midway line of these 2 lines is, we know that 2 lines are parallel. These are parallel tangent to the circles. The midway of these 2 parallel lines is passes through the center of the circle. Therefore, this line is passes through the center of the circles and these 2 lines are parallel. These are parallel tangents. And also these 2 are perpendicular. These lines are perpendicular. These lines are perpendicular because it is x plus y, it is minus y. These 2 lines are parallel tangents. The midway of these lines is, midway line is x minus y. Here constant is minus 3. Minus 3 plus 5 by 2 equal to 0. X minus y plus 2 by 2 plus 1 equal to 0. This is equation 2. This is another midway line. This is one midway line. This is another midway line. These 2 lines are passes through the center of the circle. These 2 lines are passes through the center of the circle. Then we solve these 2 lines. Solving 1 and 2. Y quotient constant, x quotient, y quotient. Here y quotient is 1 minus 5, 1, 1. Here y quotient is minus 1, 1, 1, minus 1. Therefore, the gap is x. X by A, B, C, D. AD minus BC. That means 1 minus 5 equal to y by A, B, C, D. This is arrow method. By using arrow method, minus 5 minus 1 equal to constant by this gap is constant A, B, C, D minus 1 minus 1. X by minus 4 equal to y by minus 6, 1 by minus 2. Therefore, x equal to minus 4 by minus 2, that equal to 2. Y equal to minus 6 by comparing these two, minus 6 by minus 2, that equal to 3. Therefore, the center of the required circle is C 2, 3. Next we find the radius of the circle. Actually, we need equation of the circle. Equation of the circle, that's why we read center of the circle and radius of the circle. Radius of the circle is half of the diameter. Diameter is the distance between the parallel lines. These parallel two tangents, that is the point of contact. This is the diameter. The diameter is the distance between the parallel lines. D equal to diameter. The distance, length of the diameter is the distance between the parallel lines. We take any two, we get first. The distance between the parallel lines is actual formula is C2 minus C1 by square root of A square plus B square. That equal to C2 minus C1. Here C2 is minus 1. C2 is minus 1. C1 minus of minus 9 by root of A square 1 plus 1. That equal to modulus of minus 1 plus 9 by root 2. That equal to plus 8 by root 2, that equal to 4 root 2. This is length of the diameter. Length of the diameter. D equal to, that equal to 2r equal to 4 root 2. Radius r equal to 2 root 2. The radius of the required circle be 2 root 2. Therefore, the distance between the two parallel tangents is the length of the diameter. The distance between the two parallel tangents is the length of the diameter. The length of the diameter equal to 2 into radius. Therefore, the length of the radius r equal to root 2. Our required circle, you catch that you got the center of the circle and radius. The equation of required circle B. The equation of required circle B. The equation of required circle B. Center is 2, 3 and radius is 2 root 2. And radius is 2 root 2. Therefore, x minus h whole square plus y minus k whole square equal to r square. This is h common. That means x minus 2 whole square plus y minus 3 whole square equal to 2 root 2 whole square. That equal to x square plus y square, a minus b whole square, a square plus b square minus 2ab plus a square plus b square minus 2ab equal to 4 into 2, 8. That equal to x square plus y square minus 4x minus 6y, 4 plus 9, 13 minus 8 equal to 0. Therefore, x square plus y square minus 4x minus 6y minus 4x minus 6y plus 5 equal to 0. This is the equation of the required circle. In this case, these are 4 lines. The 4 lines are the 4 tangents to the given circle, our required circle. These 4 lines are parallel to each other and one is perpendicular, one pair is perpendicular to another. Therefore, the midway of the parallel tangents is passes the center of the circle. We find the midway of the first 2 lines and midway line of the second 2 lines. The point of intersection of these 2 lines is the center of the circle. A distance between the 2 parallel tangents is the length of the diameter. Therefore, radius equal to half of the distance between the 2 parallel tangents. Therefore, the equation of the required circle is x square plus y square minus 4x minus 6y plus 5 equal to 0. If the tangent at the point P on the circle x square plus y square plus 6x plus 6y equal to 2 meets the straight line 5x minus 2y plus 6 equal to 0 at a point Q on the y-axis, then the length of PQ is, if a tangent at the point P on the circle x square plus y square plus 6x plus 6y equal to 2. Solution. The given circle x square plus y square plus 6x plus 6y minus 2 equal to 0. If the tangent at the point P on the circle, this is the circle, a point P, if the tangent at point P on the circle, point P, the tangent at the point P on the circle meets the straight line, the straight line is 5x minus 2y plus 6 equal to 0. At the point Q, the Q on the y-axis, the Q lies on the y-axis. Q lies on the equation of the tangent at P cuts the intersect the line 5x minus 2y plus 6 equal to 0 at the point Q. The point Q lies on y-axis. Then find the length of PQ. Length of the PQ, it is nothing but length of the tangent from Q to the given circle. Length of PQ is nothing but length of the tangent from Q to the given circle. First you find the point Q. Point Q is the point of intersection of the tangent and the line on y-axis. We know that this is point of concurrence of these three lines. We know that any point lies on y-axis, then its x coordinate be 0. Then it will be taken as suppose 0 comma k. The point Q be taken as 0 comma k because any point lies on y-axis, then its x coordinate be 0. This is the point of concurrence of y-axis and the given line and the equation of tangent at P. Therefore the point lies on y-axis, this line and this line. Therefore the point Q lies on this line. Therefore the point must satisfy the equation of the line. Therefore the point Q 0 comma k satisfies the line 5 into 0 minus 2 into k plus 6 equal to 0. 0 minus 2k plus 6 equal to 0. 2k equal to 6, k equal to 3. Therefore the coordinates of the point Q be 0 comma 3. In this case, then the length of PQ is nothing but the length of the tangent from Q to the given circle. Here given circle S is x square plus y square plus 6x plus 6y minus 2. Therefore the length of the tangent from Q to the circle S is root S11. This is x1 y1. That equal to square root of x0 whole square plus 3 whole square plus 6 into 0 plus 6 into 3 minus 2. That equal to square root of 9 plus 18 minus 2. Root of 27 minus 2, 25. That equal to 5. Therefore, the length of the PQ is 5 units.